see we still have some people coming in, but I think let's sit to a good time. And therefore, I'd like to say, good afternoon. And it's my great pleasure and privilege actually to give these introductory remarks and also to welcome our guest speaker on this seminar on sort of AI for education. So I'm Dr. Christopher C. from the School of Biomedical Sciences at the Faculty of Medicine in CUHK. And really, I know there are many guests joining from other institutions as well, so a very warm welcome indeed. I'll start with some brief introductory remarks, and then we'll move on to our speaker of the day. And for these remarks, I'd like to put, I'm actually using old-fashioned paper rather than anything technological to deliver these. I'd like to put the seminar into kind of the general and academic context. And I think in the general context of AI, of course, we've seen technologies like ChatGPT take the world by storm, really, very quickly transforming the way that our information from the internet is interacted with by ourselves, but really importantly by our students as well. And I was fortunate enough, I think just several weeks ago, to give a talk to some CUHK colleagues on the underlying technology of ChatGPT. And the thing I learned from giving that talk was actually there's quite a lot of apprehension and fear from teachers as they sort of digest their way through what the technology means for their day-to-day work, for the interactions with their students, and from a bigger perspective, from their career as well. And I think it's fair to say that actually we are quite behind in terms of universities and university teachers. Our policies, for example, that our CUHK just came out with our ChatGPT policy, we are trailing and we're sort of chasing these emergent technologies. And as soon as we determine some reasonable policy for, say, generative chat AIs, we then move on to new technologies for image generation, assessment, and evaluation. I think the important thing I want to say here is that these technologies are not, as they seem to be, bolts from the blue, very unknown and sudden appearances. What they represent, I think, is the latest pinnacle, if you like, of an extant technology which has been refined over time. And I want to use the example of generative chatbots, for example, where there is a very clear trail of academic literature which explains the underpinnings of the technology, the initial theories, how they were formed, the refinements from GPT to GPT-2, GPT-3 to today. It's by understanding these, I think we have this understanding, it's a performance leap, but conceptually the technologies are going through a sort of evolution, not a revolution. And this is why we're so lucky to have Professor Andy Chun, who's going to give us this viewpoint that I think is going to allow us to understand the evolution of these technologies. And really what we're trying to do with all of our works here in this program, which is AI for Education, and we're very grateful to have teaching LEG supported community of learning of AI, is to do two things, is to highlight the possibilities and also remove some of the mysteries for educators. And I hope we'll do that today. Now, it's my great pleasure to introduce our speaker for today. To be honest, to list Professor Andy Chun's achievements would really take a generative AI to do effectively, but I've done so by hand. So if there are any errors, you can actually blame me and not OpenAI. So here we go. This is my attempt. So Professor Andy Chun is both the Regional Director of Technology Innovation for Global Finance Corporation Prudential Corporation Asia, and Adjunct Professor at the Department of Computer Science for City University, Hong Kong, where he's previously served as the Chief Information Officer, CIO, and the Associate Professor as well. And this background, importantly, gives us this perspective both from industry and academia, something that's so incredibly important these days. But in addition to these former roles, he has also had roles for the government as a senior advisor to the Hong Kong government on AI and IT strategies, serving on several committees. He holds the role of vice president for the Hong Kong Computer Society and has received really a lot of awards that I can't list, but some of them that I want to highlight include AI Innovation Awards from, for example, the Hong Kong IT Excellence Award and the award from the Association for the Advancement of AI, so that's AAAI. But more than anything else, I think with his over 3 decades of technology leadership, we are very lucky and very excited indeed to hear from his insight from the evolution of AI in education. So Professor Chun, please.
Thank you, Dr. C, for the wonderful introduction. Thank you for coming to talk. So for this talk, I plan to do a different kind of format because I see from last week's kickoff seminar and the schedule for the future talks, there's already a lot of technical and academic talks on the subject matter. So instead of an academic talk on the evolution of AI in education, I would like to share a few stories to kind of illustrate, how AI has really evolved to be what it is now. Okay, so hopefully you'll enjoy it. First, let me give you a bit more background. So first is basically my story and my journey in AI. And it's been a long journey. I've been working in AI for close to 40 years. I got my master's PhD from University of Illinois Urbana-Champaign back in the 80s, and my advisors were Professor David Waltz and Donald Mickey. Oh, by the way, I hear some echo. Let me just check. So if you don't mind, maybe turn off your speaker if not speaking, because I hear some echo on my end. So sorry about that. So I did my PhD in connectionist network. So it's a kind of neural network, and I also did constraint programming and AI problem solving. So after that, I joined Professor Patrick Winston's MIT startup in Boston. So at that startup, we built AI optimization systems, mainly for airlines, airports, logistic companies, and defense. Previously, I taught at Chinese U as well as City U. Talk things like, of course, AI architecture, innovation methodologies, and digital transformation. I also work as a City U CIO for a period of years. And during that time, I created many major AI systems in Hong Kong for like the airport and MTR, which I'll talk a bit about that later. And I also created a constraint programming engine in Java that's now part of IBM's CP Optimizer. So a few years ago, I joined Prudential. At Prudential, I'm more of an evangelist for using emerging technologies such as data AI, metaverse, Web3, generative AI, ChatGPT, and basically with the goal to help customers be healthier and wealthier. I'm also responsible for global digital talent development and creating an innovation culture here. So just to give you an example of some of the things that I worked on and kind of illustrate, where are the applications of AI in Hong Kong. So I was fortunate. I helped deploy Hong Kong's first AI systems back in 1993. That's quite some time ago. And what that did is that was for Kai Tak Airport. And some of you probably never heard of Kai Tak Airport, probably was so long ago. And some of you probably didn't realize there was another airport besides the current one. So Kai Tak Airport was a original airport in Hong Kong. It's quite small. And back then it had a problem because it was too small. It was able to accommodate all the flights because Hong Kong was a very vibrant and growing city. So they searched for an AI system and they found a system that was the startup that I was talking about, Patrick Winston's startup at MIT. And I was in charge of the project. So I think this is the first commercial AI deployment in Hong Kong. And a very interesting thing about this system is that it's the first, I believe it's the first and only system that's written 100% in Lisp that's deployed in Hong Kong. So some of you might or might not have heard of Lisp. Lisp is a programming language that was used very often for AI systems, but nowadays AI could be programmed by basically any language. The reason is that most modern programming language has all these features that make Lisp popular back then. So what the system does is it helps Kai Tak Airport optimize the use of its parking space so that it could accommodate more flights and support the economic growth of Hong Kong. And it was used until the very last day of Kai Tak Airport. Also, besides using AI to optimize the parking space in Kai Tak Airport, they also use AI to optimize the use of those check-in counters because there's not enough check-in counters to check in all the flights. And this system was built after I came back to Hong Kong. So, that was working at CityU, and through their commercialization arm, created this system. So it's 100% built in Hong Kong. And instead of Lisp, it's built in using C++. And with AI, we help support Hong Kong's growth with, like 8,000 more flights in 1996, and then 6,000 more flights in 97 before they moved to new airport. And at their new airport, they also use a new version of my standard allocation system. So this is again using AI to help figure out how to make use of. So in the new airport, they have lots of gates, but the problem is that there is still a lot of knowledge, a lot of constraints that they consider because airplanes have different sizes. They park at different places. The ground staff are different. Different airlines have different ground staff at different places, and then there's marketing rules because each spot costs different. So try to consider all the constraints and rules and figure out which is the best parking spot is very time consuming. Also, you don't want a plane to park just on one spot because if it's going to be there for a very long time, you have to move it. So moving all these airplanes on the ground has to be scheduled. So this is all done by AI. It's 24/7. It's also written in C++ and using a form of AI called constraint propagation, which I'll share a bit more later on. We also use AI for MTR, and that's been used for close to 20 years, actually. So we have different versions, and it's been upgraded. And what it does is that it uses AI to figure out what kind of engineering work needs to be done each day. Engineering works could be, for example, installing those doors at where you board the train. Maybe it's maintenance of the railway lines, installing new lines, creating new stations and allocating people and equipment to do that. So it's all allocated using AI. And it's pretty complicated because there's a lot of rules involved. There's like close to 3,000 jobs per week involving 10,000 people working at night. So, at night when the subway closes, everyone goes home and sleep. 10,000 people work down in the lines to make sure the subway is in good shape. It's very fortunate we won quite a lot of awards for the system. A Hong Kong ICT award, which is the annual award of that's organized by the Hong Kong government. And then in AI magazine, that's printed by AI, which is of course the leading professional organization for AI professionals. In their magazine in 2017, they kind of search and found the 10 AI applications that they felt was the highest impact. So very fortunate this is named as one of the highest impact AI system over the past 30 years of AI back then. Singapore RT also uses similar system, again, optimizing what needs to be done to maintain the railway, to make sure that it is in top shape each day. Besides using AI for scheduling, optimization, resources, we also use AI machine learning to help the immigration department do decision making. And in the Hong Kong Immigration Department, there's a system that handles all the different kind of applications. So you might apply for a visa, a ID card, etc. And there's basically 100 different types of forms that need to process, and then there's millions of people submitting these forms annually. So at that time, they decided to digitize that and have AI process it. So what AI does is it encodes laws and regulations in Hong Kong to look at the form to make sure that, for example, if someone wants to apply for a Hong Kong ID, they have the qualifications for the ID. But the interesting thing is that there's special cases, gray areas that discretionary decision making has to be made. So we use AI and machine learning to learn from humans in these cases. So now I work at Prudential, and it's interesting when you might think, why would Prudential, an insurance company, need someone in AI? So insurance companies these days are quite different from traditional insurers. Insurance companies see themselves more of a partner in helping people stay healthy as well as wealthy. So insurance companies basically help people live longer and more rewarding life. And where do we use AI? We use AI in many different places, and you'll be surprised that this is only a small subset. So we use AI in social media marketing. So because nowadays everything's digital, and people buy things digitally. So in order to figure out who are the best people that needs insurance, for example, we use various AI to do segmentation and classification and try to predict their demographics and needs. So, the marketing side, definitely need AI. There's also AI virtual assistants. These are chatbots to answer questions about the products, AI personalization. So trying to use prediction to figure out who this person is it male, female, what are their age, what are their needs, or where are they in their life stage, what are the insurance needs, what are the financial investment needs, and then personalize a message or personalize a product recommendation. And then we use AI for propensity modeling. What that means is try to predict, if is this person, what kind of product this person needs, where this person might lapse in the payment, or if this person might need another different product. So this is basically prediction. And then AI lead management, because in a lot of products you still need a financial consultant agent to follow up. So we use AI to figure out who is the best agent to follow a particular case. AI underwriting to figure out what price should be charged quoted for a particular policy. AI dynamic pricing, so we use that in some cases where the price may change or the benefit may change depending on how healthy you are. And then of course we have an app that provides health advice, fitness advice, dieting advice, wellness advice. And there's a lot of AI in there to personalize. On the financial side, there's AI financial robo-advisor to analyze your financial needs and suggest different types of investment plans. AI customer servicing. So if you have any questions, problems, AI chatbots could kind of answer it, and then AI RPA can automate the backend processes. And then, of course, if you do need to make claim, there's an AI claim processing, and then fraud detection, and the list goes on. So that it's surprising, but there's just basically any business function, there's always a room for AI, and it's usually working in the background, so you might not notice it. Okay, so that's my journey in AI. Applying different techniques to solve real world problems. And what I like to do is more of the evolution. Next is the evolution of AI and how it relates to maybe education, by telling the stories of three professors that I have a personal connection to. These are the two thesis advisors, David Walls, Donald Mickey, and then Professor Patrick Winston, who I work for in his startup when they just started the company. So hopefully by telling story of their journey and the evolution of the technology, you kind of see how AI has evolved over time. So first, let me tell a story of Patrick Winston, and the story relates to knowledge graphs. Patrick Winston, for those who have been working or studying in AI, you probably know him. He unfortunately passed away a few years ago. So he was the head of MIT's AI lab for, I think, 25 years before he became a Seashell, the commercialized AI lab. And he is a pioneer in machine learning. If you study AI, you probably see this book. This is the very first book in AI, and it's written by him. And a lot of schools use that for their textbook. So Patrick Wilson, one of his seminal work is his PhD thesis, which he did in 1970. And in his thesis, he tried to figure out a problem is, given an image of some sort of toy blocks, how do you get AI to recognize a different structure? So here he's teaching AI how to recognize this as an arch. And then what his thesis really saying is that, in order for AI to learn something, not only do you need to give it positive examples, but you also need to give it negative examples. So for example, if these two columns touch each other, then it's no longer arch. And if you don't show a picture of two columns touching each other, AI will not learn the fact. So the result of the learning is a graph like this. We call this semantic network. So it's a way to represent knowledge in AI. And the different nodes represent different concepts. So it's an arch is is made of breaks. There's two parts, two breaks, and then there's a polygon on top. The breaks must not touch each other, and then the break supports this polygon at the top. So it's a polygon because it could be a break, or it could be a triangle. A pyramid, or anything else. So this is called semantic network. We call this knowledge graph now. So it's a new word. And knowledge graph is used very often to represent knowledge. So here, this is a SNOMED, which is a kind of ontology that explains the different terms used in medical. So this is actually a knowledge graph of the original SARS, I believe. And it tells different concepts. So it says, SARS is kind of disorder. And then there's relationship between these concepts. So is viral respiratory infection, is a coronavirus. The pathological process, infection is transmitted through infection. The causal agent is SARS, symptom-related coronavirus, et cetera, et cetera. So it's more complicated than that, but there are people who are designing these structures, and it's standard structures, and there's many places where you could find these taxonomy. Insurance companies use that as a way to standardize diagnosis, etc. So I'll just give you one example application of this. So knowledge structures, knowledge graph like that is used by Babylon, which NSS in UK uses as well. So it's embodied in the app that you can download. It's free. It's also available on desktop. So you can download the app and use the AI inside. So what the AI does is that it has millions of concepts and relationship on different symptoms, different diseases, and how they're spread, and then also the diagnosis. And through this gigantic network of concepts, medical concepts, AI trying to find a diagnosis for a particular person. And in this demo, I have a video of this that I could show. It shows how AI is talking to a person to figure out what the illness is by traversing this gigantic knowledge graph. So let me just play this video for you.
Alexa, I want to talk to Babylon.
Hi there, I'm Babylon and I'm here to help. To start, tell me what symptom is bothering you the most.
Well, I've got quite a sore stomach.
Sorry to hear that. Let's figure out what's causing your pain and how to treat it. Chris, where exactly is the pain?
It's kind of on the top part of my stomach, sort of in the middle.
And how bad is the pain?
Oh, it's not too bad.
And does it come and go?
Yeah, it comes and goes, and it's worse after eating.
I see. How would you describe the pain?
Sort of feels like a burning pain.
Okay. And are you feeling sick?
Yeah, a little bit.
Have you vomited at all?
No.
Have you noticed you're feeling fuller sooner than usual?
No.
How long have you had this pain?
A few months, 3 months maybe.
Are you still a non-smoker?
Yes.
Okay, that's great. Have you been taking any of your ibuprofen tablets the last few days?
Yeah, I have.
Thanks, Chris. I know enough now to offer information on what may be causing your symptoms. It could be acid reflux or a peptic ulcer. I'd recommend speaking to a GP soon. They're likely to prescribe something called the proton pump inhibitor to control your stomach acid. I can then get this prescription to your home using your Amazon Prime.
Okay, thanks, Babylon.
My pleasure. Thanks for using Babylon with Alexa. Goodbye.
Pretty amazing, huh? So that is real. This is not a demo. It's actual system. This is 5 years old. And like I said, you can go and download and try it out in the app. It's free, and it's pretty amazing. It's also I think it's a very good tool for medical students to learn all these medical knowledge and how it's used. And besides talking to the patient, the doctor in the background has an AI system, and I want to show you this. This is it's amazing, interesting AI system. So because it's a mobile app, the doctor can see the patient, and AI can analyze the facial expression to see if this patient is anxious or is puzzled. Next, on this side, on the left-hand side, is the past medical history, and this medical history gets updated automatically by AI. Down in the bottom left is the digital twin. This is the result of previous health checks, and is basically an internal digital model of the organs of the patient and their statuses. In the middle, in the middle, are AI suggested questions. So as the doctor talks, AI dynamically suggests questions for the doctor to ask and remind doctor of things. At the middle and the bottom is the AI reasoning. So it dynamically, continuously reason and try to figure out what are the most likely causes for the symptoms. It recognizes special clinical codes, automatically updates that on the right top. In the right middle is a audio transcript of everything that's said. And then at the bottom is AI generated consultation notes. So let me show you how this works in a live demo.
Hi Louise, my name's Dr. Kultag Archer. Nice to meet you.
Hi, nice to meet you too.
So I can see you've completed our AI assessment. And from this, can I confirm that you've been having dizziness for a few months now with some hearing loss and also some ringing in your ears?
Yeah, that's right.
Okay, you look quite comfortable at the moment. So does the dizziness come and go?
Yeah, I don't have it at the moment.
Okay. And when you do get the dizziness, how long do the symptoms last?
A few hours at a time, I'd say, probably. Yeah.
Okay. And does changing the position of your head bring on the dizziness? Sorry, what I mean to say is, do you get dizzy, for example, when you turn your head to look to one side or when you turn over in bed?
Oh, okay. No.
Have you felt sick or vomited when you get the dizziness?
No.
Okay. And is there anything else you wanted to tell me about your symptoms? For example, have you had any headache, any weakness, any numbness at all?
No.
Okay. According to our records, you also had glandular fever a few months ago. Has that all settled?
Yeah, that was awful. That's gone now.
Great. I mean, just looking at the blood test results from back then, they all came back normal as well.
Great.
So I would agree with our AI assessment. It looks like your symptoms are being caused by an ear condition called Meniere's disease. This causes a buildup of pressure within the balance center. And that's what causes those awful dizzy episodes that you've been getting.
Okay.
The most important thing now is to relieve those awful symptoms. So I'd like to prescribe something called prochlorperazine. Can I just double check you're not pregnant at all?
No chance of that.
And you're not allergic to any medications?
No.
Okay. So I'll send that prescription to your usual pharmacy. It'll take around an hour or so.
Okay.
Does that all sound okay?
It sounds a little bit serious.
Well, as you found out, the symptoms can be really serious when you have them, but many years itself usually isn't, and it can be really well managed with the medication.
Okay, thanks.
One thing to mention, given that it looks like you do have Meniere's disease, this could put you at a high risk of getting migraines. So I'd like you to do our migraine risk assessment, and that way we can see if there's anything that we can help you to reduce your risk.
Okay, yeah, I'll definitely do that.
Great. Okay, so I'll just run through the next steps confirming your diagnosis and how to take the medication safely.
Pretty cool, huh? So as you can see, there's a lot of things going on, but AI acts as a assistant that takes all the notes and generates the doctor consultation report, as well as do the prescription. And in UK, those prescriptions could be sent to a pharmacy that would maybe deliver to your home, so you don't need to go out. Full disclosure, Prudential has an app called Pulse. It also has this AI inside, so if you like, you can download the Prudential Pulse app and try the AI yourself. Knowledge graph, so that's an example of how knowledge graph is used in real life. Knowledge graph is also used in Google. So if you Google for Alan Turing, you probably see a lot of information. And then on the right bottom, you see this about where he's born, where he died, and so forth. Internally, Google represents the knowledge graph like this form. So it looks like the semantic network that Patrick Winston did long time ago, but obviously knowledge graph these days are huge, millions of nodes, gigantic knowledge structures. Knowledge graph is also used by in education. So how is that related with education? So basically all the adaptive learning sites, like Newton and many others, they use a knowledge graph that kind of indicates, what are the different, knowledge concepts that a student need to learn, the relationship between those concepts, and through quizzes identify what the students have learned, and then maybe identify areas where the student need to improve upon. And after Patrick Winston passed away, he MIT uploaded one of his lectures. So he, besides being a pioneer in AI, he's also very famous. And every year he gives a talk on to teach professors and teachers and students how to present and how to speak. So this annual event is attended by hundreds of people each year. And they uploaded, MIT uploaded his lecture onto YouTube. So if you're interested, you could go to YouTube and search for how to speak, and it's very valuable. You could change everyone's presentation. There's something that you could probably learn from. Next, I want to share the story of Professor Donald McKee. He was one of my advisors when I did my master's degree, and he was at that time doing his sabbatical. So he's from UK, Edinburgh University, but he did his sabbatical in University of Illinois Urbana-Champaign, and that's where I met him. And he's a pioneer in game playing. And his story actually starts with this. I think a lot of you probably have seen this movie, The Imitation Game. This is the movie about how Alan Turing created a machine that broke the German secret code and helped the Allies win World War II. And one of the persons that helped Alan Turing build the machine was my professor, Donald McKee. And let me just, and this is what Donald McKee looks like. He unfortunately passed away, like 10 years ago, and was in a car accident. But the interesting thing is that after he helped Alan Turing build this amazing machine, he went on to get his PhD because he was a young man back then, and went on to get his PhD, and he decided to create a machine learning algorithm to play tic-tac-toe. Now, because it was right after World War II, he had no computers, So he had to, but he could still create an algorithm, because an algorithm could be run by any machine. It doesn't have to be a computer. Computer wasn't quite readily available. So what he did was, and this is amazing, because back then computers just crunch numbers. So no one would ever thought about having a computer learn something. And what he did was he used, because he doesn't have a computer, he used matchboxes. So I have to show you a picture of matchbox, because I'm not sure people know what's a matchbox anymore. So what he did is he built a computer out of matchboxes. In fact, hundreds of matchboxes. I think like over 200 matchboxes. And what these matchboxes represent is each combination of states in tic-tac-toe. So there's over 200 combinations, and each box represents one of them. And inside the box are colored beads. Different color represents a different move. And in order to play the game, he would take depending on the current board position, he would take that associated box and shake it and take one color beat out, and that color beat will tell you what is the next move. And then you'll play the whole game, and then if it wins, then it will go back to find all the boxes that contributed to the win and add one more of that color beat to the box. But if it lost, it would try to take one beat out of the box as a penalty. So this way, and then through several cycles, this computing machine learned how to play tic-tac-toe pretty well. So what he really did was kind of reinforcement learning, or we call it credit assignment problem. So reinforcement learning is a machine learning training method based on rewarding desired behavior. So if it does something good like winning, then you give it a reward. And if it was part of losing, then you punish it, or you penalize it. So what it does is figure out what it did that contributed to the win, or what it did contributed to the undesired behavior. And in this case, it finds all the boxes that contribute to win, and then rewarded it by adding a appropriate color beat to the box, so that you would do more of that. But if it lost, it would take one of the color beads out to penalize it, so that it would not do that again. So this way of finding out what went wrong and then penalizing and giving credit is a popular technique. It's used in backpropagation network, which is one of major machine learning algorithms. So the way it works is that as signals go through a neural network, if it gets the wrong answer, then it goes back and find all the links that contributed to the wrong answer, and then reduce the link weight. If it contributed to the right answer, it goes back to all the links in back, and then reward them with additional weight, so that it does more of the good things. So this kind of backpropagation is used also in LaNet and CNN for face recognition, handwriting recognition, as well as OpenAI, ChatGPT. So ChatGPT, of course, is a combination of human and machine learning. And as you probably all know, ChatGPT 4 just came out yesterday and was able to do quite a lot more than ChatGPT 3.5. And so I tested one of the problems that they asked ChatGPT 4 to do. And ChatGPT 4 is available only if you pay subscription, but it's also available in Microsoft Bing. So if you want to use ChatGPT 4 but don't want to pay subscription, you download the new Bing. But there's a waiting list to use it. I subscribe to the new Bing. I put my name on the waiting list, I think a week ago, and I got it in 3 days. So here I'm testing it to make sure that's the ChatGPT 4. So I use the same problem. Explain the plot of Cinderella in a sentence where each word begins with the next letter in the alphabet from A to Z, without repeating the letters. So it came out with A, beautiful Cinderella. So it's A, B, C, D, E, F, G. Then I said do it for Snow White, and then it tells a story of Snow White with A, B, C, D, E, F, G, and then Sleeping Beauty. It's kind of fun. So you could try it out. In terms of using AI in education, so ChatGPT is a major tool that could be very valuable for education. So Singapore government announced last month in February that they're planning to use ChatGPT, but they'll teach to students how to use it properly. So there's many aspects to using it properly. First of all, how do you ask the right question? So that's prompt engineering. And then also teaching teachers how to integrate ChatGPT into their coursework to give exercises that might be using ChatGPT. And then also the proper academic approach to using different sources is to give it to attribute that this particular work has been done, or part of the work has been done with ChatGPT. So it's like quoting your references and so forth. So ChatGPT need to be acknowledged that it's been used and so forth. Different academic tools are using ChatGPT for example, Khan Academy, which is very famous for providing videos, and it has also acknowledged Graph for adaptive learning. It's been using ChatGPT 4 to act as a tutor. So instead of giving a student the answer right away, it kind of lead and guide the student in learning to come up with the answer themselves. So that's very interesting. I tried ChatGPT with a real life example. So here, this is BMW Group's annual balance sheet for the year 2021. So what I did is I cut and paste this entire spreadsheet and then asked ChatGPT, can you identify the risks from the spreadsheet? And ChatGPT within a couple of seconds was able to tell me that this is the balance sheet is strong. However, there's some risks, financial liabilities, low level pension provision, inventory level has increased, and so forth. So it's amazing tool. It could do hundreds of different things, and the key is to understand how do you phrase your question so that does the right thing. So that's prompt engineering, which should be an integral part of our education in the future. A lot of you probably never heard of Donald Mickey, the story that I was told, but amazingly, actually, his legacy still lives on. So if you're a developer, programmer, so you might heard of memoization. So it's still used today in all the programming languages in JavaScript, React. So memoization is something that Donald Mickey invented back in 1968. So look it up, they're interested. So Donald Mickey, so interesting fact is that, I'm 2 degrees of separation to Alan Turing, because Donald Mickey is Alan Turing's protege, and I work with Donald Mickey. And it's really cool because you guys, everyone who's in this webinar now, are 3 degrees of separation to Alan Turing. Congratulations. So I talked about Patrick Winston's story of AI and how that evolved, talked about Donald Mickey. So last story I want to share is a story about David Waltz, who is really the main my main PhD supervisor. So he did a lot of work in constraint propagation, spreading activation. So David Waltz, he passed away a few years ago, 10 years ago actually, from brain cancer. So it's unfortunate, but his work, he did a lot of work in many different areas. But I think his main contribution is he came up with an algorithm, which now is called Waltz filtering algorithm, which make computer to be able to solve very complex problem in a very fast manner. And I use that often in my work with the optimization for MTR and airport and so forth. And he did his PhD thesis in 1972. And what he did was that he said, one of the key most difficult tasks for computers back then is, you're given a picture of all these blocks, but how do you get a computer to understand what those lines mean? And back then it was too complex for a computer, or take too long for a computer to figure out all the different meanings of the lines. You had to run for months or years to do it. And what he did, his contribution was that he created an algorithm that made it fast. So for each line in that line drawing, there's many different ways of interpreting it, and it's very simple. There's a negative and positive. Positive means the is convex towards you. Negative is concave away. An arrow means that the solid is on your left hand side. So this might be a block on the ground, and this might be the ground's on this side. And he realized that there's only a certain combination, and by propagating the constraints, you could solve this problem much faster. So here is a line drawing that you might give the computer, and this is how the computer might interpret the meaning of each line. Now, the way it does that is that it's interesting because it's the more complex the problem basically is, the easier it is to solve, because there's only a limited number of physically feasible solutions to that. And by using his technique of propagating constraints, so for example, if the interpretation of this line is positive, then it must be positive on the other side. If it's negative, then both in the line has to be negative. And then if there's if lines are jointed, so that kind of reduces the possible interpretation of that scene. And I found this video. This is 50 years old, that kind of animated his constraint propagation. So let me just play it and then talk about it. So there's a number that shows up, the possible combinations. So originally there's 123 combinations if you look at individual lines, but you combine two lines together, there's 78. But then if you start to look at adjacent lines and adjacent corners, and then propagating the constraint from this to here, the number of possible combinations have reduced. And then going back, that reduced the possible. So what that means is, if this is a positive interpretation, then it has to be positive at both ends. So you can see instantly the number of combinations have been reduced very quickly. And then let me just fast forward here, and then eventually this algorithm comes out with an interpretation of the scene. And it does that in a very fast way. So if you use traditional approach where you try each one out, it'll take too long a time to do. I see there's some questions. Yes, so let me just answer one question. There's a question about AI tools and software besides ChatGPT. There are just so many. I think most, and as I'll mention some here. So there's tools to help students learn English, for example. There's tools to help students learn math. The thing is that many of the tools that you see nowadays that's related to learning or e-learning, there's already AI inside. They might not necessarily mention AI, but they're very often, any software that you use, if it's useful, very often there's AI. So this simple technique of constraint propagation, although it seems simple, but it's very powerful. So it allows companies to be able to solve really very complex problems in a very fast way. So that constraint propagation is actually used in IBM iLog CP optimizer, and I wrote the Java CP engine for this. And if you are interested in constraint propagation, there is a site in IBM that tells you more about that. Now, lots of things, there's ambiguity. There's many interpretation of the same structure. So, for example, in this diagram, this cube, there's different interpretation. For example, the cube might be on a table. The cube might be stuck to a wall. The cube might be stuck on the wall on the other side, etc., etc. So this ambiguity in understanding what a scene means interests Professor Walls. So he applies that to natural language understanding. So there's classes of the sentences where there's potentially two meanings. And here is an example. So this is a type of it looks like semantic network, but it's actually a neural network. So it's a type of neural network that's called connections network. And those links are connected to other links and activations are spread just like neural networks. So in this example, the network has both the grammatical structure as well as different meanings of the words. So the sentence is John shot some bucks, and if you're talking about hunting, then bucks means deer. So John shot some deer. But if you talk about gambling, then that means John lost some money. And what Professor Waltz did was he created a structure that could allow a computer to understand both meanings depending on previous context, what you were talking about before. So in this case, it was talking about hunting before. It would parse the sentence properly with the proper meaning. And that's after 50 cycles of spreading activation. And for fun, I decided to ask ChatGPT, see if it could also understand the different meanings. And amazingly, it did. So it says, oh, and actually it did better. So it said there's 3 meanings, not just 2. So one meaning is to kill some deers, another meaning is loss of money, but third meaning at the bottom is that because bucks is buck skin is leather, it's made of shoes. John shot some bucks means he wasted some shoes, and this example is maybe John Lennon, a famous magician, of course, and part of Beatles. When he was born, he was famous for collecting and destroying shoes. I didn't know that, but so that could be another meaning. In terms of education, it's very common for using AI to do natural language understanding, and nowadays we use that capability to help students understand English. And there's so many tools. So Grammarly is one example. There's I think like 24 or more tools that uses AI to help students, check the grammar, help them rewrite their paragraph to be better in different voices, summarize, and some of the system uses ChatGPT as well. It could give students ideas, come up with outlines and so forth. So natural language understanding and AI is very often used in tools for language understanding. Last thing I want to talk about is the question that everyone asks, will AI replace professors or teachers in the future? And I think everyone's eager to know. So we look back 1,000 years. So this is a picture of the first university, University of Bologna in Italy, and the building still exists. So 1,000 years ago, the reason for people to go to university is universities are where the books are, because printing hasn't been invented. So in order to learn anything, all the information is in the university. And professors has access to those books. So in order to learn, you must go to university. But then things change. The printing press was invented, and then books were readily available. So you no longer need to go to university, but still, books were expensive. And then the internet was invented, and with search engines. So people would say, "Oh, well, with search engine, you can find all the information in the world. Why do you need to go to school, right?" But we still need to do that. And then there's Wikipedia, and the Wikipedia is like the encyclopedia of everything. And if I remember, and you remember back then when Wikipedia was invented, teacher was and school said, "Don't use Wikipedia; it's not accurate. You cannot rely on Wikipedia." And now we're kind of saying the same thing for ChatGPT, but it's true. ChatGPT is not reliable because it reads only information that's from the web, and it's only updated to 2021. And so you need to learn to verify your sources. But at the end of the day, we still need to. So all those tools are readily available. So what I think professors in university realize is that universities is not just a place where you just get information, because you could get that information from books, from web searches, from ChatGPT. I think the most important role for a professor is really to understand the individual needs of a student, what their aspirations are, or what are their goals in life, and then maybe find ways of learning to help them achieve those goals. And and education is not just it's not just getting information. Professors are good at coming up with problems for students to solve, and AI and like ChatGPT are not able to solve new problems. They're not going to be creative to come up with solutions to problems that we never seen. And there's new issues and new problems that we face every day in the world. Like COVID. How do we solve a problem like COVID? How do you invent new virus, new drugs for COVID? And so you cannot just ask ChatGPT for a solution. So coming up, encouraging students to be creative and use what they know to create solutions to new problems is something that that a computer AI cannot replace. Also, an educator is more than someone that gives information. Educator is a person that students look upon as a role model. So it's a role model to inspire students to be passionate and enthusiastic about knowledge and learning. And I'm sure, I don't know if AI is going to be inspiring to students anytime soon. So I think, teachers are in good shape. But let me ask ChatGPT what it thinks. So let me. So I asked ChatGPT, if ChatGPT is going to eliminate the need of university professors. So ChatGPT was, very humble. He says, no, it's not going to eliminate the need for professors. ChatGPT says an AI-powered chatbot to generate natural language is no substitute for human intelligence, creativity, or expertise. University professors have many roles and responsibility that ChatGPT cannot perform, such as designing and delivering effective curricula and assessments that align with learning outcomes, inspiring and motivating students with their passion and personality, fostering creative thinking and creativity among students, and providing ethical guidelines and social responsibility to students, collaborating and networking with other professionals and experts in their field, mentoring and supporting students in their academic and career goals. So ChatGPT is a useful tool to enhance teaching learning, but it cannot replace university professors. So there you have it from AI. This concludes my talk and sharing on how AI has evolved over the past 60 years and how it relates to some of the modern technology that you see and how it relates to education in general. So I'm happy to answer any questions that you might have.
Great. Just while we're waiting for questions, Professor Chun, that was amazing. Thank you so much for sharing with us that. I think it's great to see the journey, not only your journey, but you've illustrated your journey's experience through the evolution of AI. And I think it is at least somewhat reassuring, although, of course, I think when I see some of these technologies, particularly the medical ones, I'm quite amazed that that's sort of 5 years old and it's perhaps outperforming me in many ways. But perhaps we'll take some questions. I think there is one question in the chat box from Pang Hui, who is asking about, apart from Grammarly, which seems to be focused on feedback, any intelligent tutoring systems that's more focused on teaching, training, practicing, or other language aspects? Any thoughts?
I haven't tried them out, but I believe things that Khan Academy is doing is similar to what you're looking for. It's more of a tutoring system. So the example where Khan Academy uses ChatGPT for not to give answers, but understand what are the knowledge that a student need to solve the problem, and then guide the student in learning those concepts. So instead of giving the answer, is really teaching the students the concepts and having the students learn by themselves. So if you're interested, take a look at Khan Academy. but I think it's still under development. It's not for general use. But those tools that is more of adaptive learning, where they understand and have a knowledge graph or what the student already learned, and be able to kind of guide the students in learning those missing gaps in knowledge are what you're looking for.
Thank you. And may I just add on? I think for nowadays, for the modern academic, it's not enough to do a literature review, but I think there's several other databases we always have to check. Number one is the App Store. Actually, we always have to, because the commercial is often ahead of reported results in the literature. So I think we ought to check what is available there. And the second thing is actually our students. So I have several students who are already using Notion AI, which is a sort of a document management website to summarize my notes and their notes for their academic studies. And I was alerted to this by them and not the other way around. So I think these are two other sources that, in addition to the literature that will report on the investigational side and perspective side, I think we ought to be looking as well at the commercial, because they are progressing very fast.
I totally agree. I mean, if you do look around, there's literally hundreds and hundreds of tools that uses AI, and not necessarily ChatGPT, but many different types of AI in the education area. So use Google and try out to look for appropriate tutorial tutoring tools.
Okay, perhaps we'll make this the last question, and thank you, Wick. So since you've been a participant to experience AI's evolution, what is your forecast or opinion for the next AI evolution?
Well, I mean, it's really amazing to see how AI has evolved. I mean, it was a shock to see AI be able to play and win humans against a game of Go. Back a decade ago, that was mind-boggling, because Go was, everyone knows that was the most difficult game, and AI able to solve it. And then, transformer technology came about, and GPT, and it was again mind-boggling to see AI come up with text as well as images and supposedly videos very soon. So next AI evolution, I think AI focus right now is mainly on replicating what human can do. So I mean, next evolution, if there's any, is that AI will be more creative in coming up with solutions. But if that happens, it might not be a good thing, because you all heard about the AI singularity. If AI is so smart, doesn't need humans anymore. And I think it's evolving at a rapid pace. The main reason for the evolving of AI so rapidly in the past few years is because hardware is getting cheaper. There's cloud computing. Instead of just doing some machine learning on a small sample subset of data, you can do AI machine learning at scale. And what that means is to learn entire open well, everything that's on the well. That's powerful. And then give you an everyday example is Tesla. Tesla car learned how to self-drive by watching every Tesla driver drive every day. This is machine learning at scale, learning from the whole entire humanity. And that's very powerful and very scary at the same time. But hopefully the day that singularity comes will not be in my lifetime. I'm sure, hopefully.
Excellent. Well, thank you so much. Well, thank you everyone, first of all, for your questions, and a very big thank you from all of us, from all the institutions, from our team here organizing the AI for Education community of learning. And Professor Chun, I know everyone's camera's off, but I will sort of lead the team in giving you a very warm round of applause. So thank you so much indeed. And I think just one service note, I think we'll call that an end to the seminar. And I would just like to give one very brief service notice that our next event in this seminar series is going to be on the 4th of April. One of my very favorite speakers and collaborators, Leon, if you've ever sort of heard him and seen him do his thing, he's great as a teacher, but also he's been working with this machine learning classification of the United Nations SDGs, the Sustainable Development Goals, through very large mountains of data and course descriptions across multiple universities. This is going to be a 2-hour Zoom meeting and looking at how he's achieved these excellent outcomes. So please do join us for that. And with one last farewell to Professor Andy Chun, and thank you again for your time. Thank you, everyone, and we'll see you at the next session. Thanks. Bye-bye.
Bye, everyone.